Hello everybody. We are heading out for problems number 21 through 40 on exam 2. So we are starting at number 20 and these 21 through 30 went pretty quick, so I think you'll like that. All right, our first one here, we have a contingency diagram, a two-way table comparing GPA and grade level. All right, and we are asked to find which of the following statement is not true. Well, A ends up not being true. It says about 39% of the sophomores have at least a 3.0 GPA. So at least a 3.0 would include, for sophomores, those 121, or they could belong to this group, 143. So the total sophomores that have a GPA that is at least 3.0 is 121 plus 43, or 164 out of the total of sophomores, which is 310. So let's take a look at that really quick. All right, so greater than 3.0 includes those two categories, and those are amount of sophomores in each one. Okay, that ends up being 21.5%, which is not greater or equal to 39%. And again, 310 is the total amount we're only talking about of sophomores, okay? So let's look at the other ones here. All right, the other ones say, whoops. B, sophomores represent 35% of GPAs from 3.0 to 4.0. So sophomores would be 121 out of the total 310, which is not going to equal 3.9%. Okay, and then finally seniors represent 20%, 29% of reported GPAs. So seniors, all seniors, 29 out of the total is not 29%, you'll find. Only about 3% of seniors have GPAs less than 1.0. Okay, less than 1.0 for seniors. Okay, so we're just talking about seniors. 7 out of 219 seniors is what that one is, and that is not less than about 30%, excuse me. And you find the 11% reported GPAs are juniors with GPAs from 2.0 to 3. So talking about out of the total, 11% of the total ones are juniors with those GPAs. So GPAs, juniors from 2.0 to 3 would be 84, okay? Sorry, I think I restated that wrong. 11% of the reported GPAs are juniors with GPAs from, so I'm doing that right. Okay, so junior with GPAs 2.0 to 3 is 84 out of 762 is not going to be 11% there easily. So A fails that one. Sorry, I messed up on that one myself there. All right. Okay, moving on. 22. All right, coefficient of determination between two variables, that's R squared. Said it's 81%. Remember that R could have been negative or positive, so we don't know because when they square it, it becomes positive always, okay? So it says large values correspond with large values of the response. As the explanatory is getting bigger, the response is getting bigger, going uphill. No, we don't know that. It could have a negative R value, correlation coefficient, because R could have been negative. We don't know that. We can't tell by looking at R squares. So that one's not, must be true, no. Large values of the explanatory correlate with small. That would be a negative. It could be, again, we don't know. That's the same as A. We don't know if it's positive or negative going uphill or downhill. Cause and effect relationship exists. We never, ever, ever show that through linear regression. So that one's definitely false. It's like your worst choice of all of them. Okay, D, there is a strong positive linear relationship between the explanatory and response variables. That would be great, except it says it's positive, and we don't know it's positive again because we're just looking at R squared. Okay, and then I'd have to square root that to find out what R was, but that would be in the strong category, I'm sure. Finally, approximately 80% of the variability in the response variable is explained by the linear regression on the explanatory variable. That is what we're looking for. Okay, and typically on this one, when they talk about R squared, you're looking for the term variation or variability in that answer. That's almost always the right choice because that R squared explains the variation in whatever's on your y-axis. Okay, and that's almost always the case for these problems. So E is my correct one for 22. Okay, this one's a little bit tricky here. All right, so carbohydrate contrast. I'm sorry, guys. I'll slow down. My mind goes quicker than my mouth. carbohydrate content in grams for serving sizes of dairy, fruit, meat, and vegetable is recorded, and here is my information. Okay? Dairy, fruit, meat, vegetables. Okay, which of the four categories would have the smallest value for all measures of spread? Measures of spread here would be the IQR, they would be the range. Those are the two measures of spread we're talking about. Measure of the spread would not include the median. We don't care if it's high or low. We're talking about how spread out the data is. Okay, so let's pull up here. F has the largest because that range is by far greater than the others. Okay, now this one and this one are really close, and this one could be smaller, okay, but the IQR is bigger than this one. You guys see that? Okay, and this range is bigger than this one. So let's go back over that again. So this one has a slightly smaller range than this one, but this IQR is bigger than that. Okay? And this one has a slightly smaller range than that, but its IQR is also bigger than that one there. Okay, what's going on here? Why is there no line in the middle? Because the median line was probably right on that quartile 3 line right there. Same with this one. I can't tell if that's one line or they could be separate, but it looks like it's right in there in the middle. Okay, but this one here again, it's all together. Quartile 1, quartile 3, and the median look like they're all kind of in the same spot. Okay, all right, when I go to my answers though, so it's kind of a mix there, but if you go check it out, it says meets with the outlier removed. Okay, meets, if you take away that outlier, it has a tiny range, has almost no IQR. Okay, and yeah, all measures of the spread are tiny on that one. So correct answer there, E. All right, 24. Okay, really common question, guys, really easy. Okay, they're going to talk about the correlation. Okay, they tell you the correlation is negative 0.346, and then they're going to change the units of one or both. Okay, but what you need to know is changing the units, like it doesn't matter, it doesn't affect the correlation. So if age and height were correlated, okay, meaning they have a strong linear connection, let's say between the ages of, I don't know, 5 and 15, the older you are, the faster you're growing, your height's changing, okay? If that had a strong correlation, it wouldn't measure, gosh, I'm so sorry. I'm failing you guys in my English here. It wouldn't make any difference if I measured the people in the metric system or the inches, they would still have that relationship would still go on. So changing one or both sets of units makes no difference. So the answer is pretty much always the same. Okay, what would happen to the new correlation? Oh, it'd be the same, 0.346, because correlation does not depend on units in any way, shape, or form. We are moving along here. Other than me not being able to speak, we'd be doing great. Okay, 25, here we go. Data are collected from zoos for the age at death in years for black bears and grizzly bears. The graphs below model the data collected from the zoos. Let's talk about these, and I would do this if I was doing my AP exam here. If I was taking it, I would look at this and analyze the graph and then go get those questions. Okay, these are the grizzlies. Okay, watch what you can see. They're more, these are the black bears. These are the grizzlies over there. We can see the black bears are more spread out than the grizzly bears are, okay? So the black bears would have a higher standard deviation, where any measure of spread or range would be higher than for the grizzlies, okay? The average age of death for the black bear looks to be around 18, while the grizzly looks to be 25 or 26 out there. So the grizzly look like on a whole, they live longer. Not all grizzlies, because some grizzlies die here and some black bears live longer than they do, up to 26, okay? So that's what's happening. Let's go see what the question is here. Okay, which conclusions can be drawn? Okay, grizzly bears tend to live longer than black bears. True, but their variability is smaller. Okay, their variability is smaller than the black bears. So that one looks like it's true. Okay, B, black bears tend to live longer. Okay, that's false because black bears live shorter right there. Grizzly bears live longer. True. Their variability is larger. The grizzly bear variability is only from here to here, that range. The black bears is much larger. That's false. And finally, the last one here, black bears tend to live longer. That's false again. Black bear's average death is here while grizzly's over there. So choice A is my correct one there. All right, that is it for 25. Woohoo! I said, if only I could speak. You'd be doing great. Okay. All right, here we go. This is a sample size problem. Now watch, this is a regular one. The other one I told you is kind of a weird one because they gave you a mean instead of a proportion. This is a normal problem that would be on your AP exam here, so I like this one. Okay, a large school district, the Food Services Administrator wishes to determine the proportion of students who will buy a school lunch to within plus or minus 3%. That's your margin of error right there. Using the most conservative estimate for P, they don't tell you that normally, okay? They don't need to say anything. They just say they're gonna have a 90% confidence level, and if they don't tell you the proportion, you know that you have to put in 0.5. That's what we always use. So let's take a look at this one real quick. This is number 26. We don't have, I went through these. 26, okay? Remember our confidence interval normally is p hat plus or minus the margin of error, and the margin of error is in blue there. It's your z-score for a proportion. Remember it was t for a mean. That's another reason why they don't give you a mean problem for sample size, okay? N times p hat, q hat over n. They haven't told us p hat and q hat, so what do we use? 0.5 for those. Okay, how do I find the z-score for a 90% confidence interval? A 90% confidence interval has 10% outside of it, 5% on each side. So we're gonna go inverse norm for a z distribution, and we're gonna put in 0.05 for 5%, okay? That's the area. The mean is already set for you at 0, and the standard deviation is 1, and you'll find it is 1.644, okay? Doing my math here. I have, this is my equation now. I know that 0.5 times 0.5 is 0.25. All right, so my first step is to divide by 1.644. After that, I'm gonna square both sides to get rid of the square root. I'm here right now. Once I'm there, okay, I'm gonna multiply by n and I'll divide by this quantity. There it is right there. Okay, and my n value is 750.76 is what I got. That would always round up to 751. The closest answer they have is 752, so we would choose that. And that is, and I wrote it here, it looks like answer D is that correct one, okay? So this is a good one, guys. You should know how to do this problem right here. And if they tell you P, you put the P in there. If they don't, you put in the 0.5. It's like the same math. All right, 27. Moving along. I think I did a little better speaking on that one. If two events A and B are mutually exclusive, oh, what does that mean? That means the definition of mutually exclusive is two events share no outcomes and cannot happen at the same time. So if that's true, then the probability that A and B occur simultaneously would be 0, okay? They cannot occur at the same time. That's what mutually exclusive means, so A is my correct choice there. T distributions, okay? T distributions, what are they like? Oh, they are unimodal, they're mound-shaped, they're symmetric, they're almost the same as the Z, okay, but there's more at the ends, at the edges, and they don't follow the empirical rule, so they're not normal, okay, and according to the AP exam, there's different things. For you guys, you know you use them every time you have a mean problem, but according to the AP exam people, we use them when we don't know the true standard deviation, okay? So let's take a look at that, which is not a characteristic. T distributions are mound-shaped, yeah, shaped, and back to my old reading again. T distributions are mound-shaped, yes. Okay, centered at 0, yes. T distributions have more area in the tails, yes. Okay, T distributions use S as an estimate or a sigma. Again, we don't use sigma, we don't know it, so we use S when we're using the T. That's what we do always, so that is a true statement. Finally, as the number of degrees of freedom decreases, gets smaller, okay, the T distribution approaches the normal. That one's backwards. As n gets larger and larger, the degrees of freedom get larger and larger with it, because typically they're n minus 1, right? So, and when n gets large enough, then the T becomes essentially the same as the Z. But this is backwards here. It said increases, that would be true. So E is my answer here. 29. Okay, we had one of these yesterday. This one's better. I'm okay with this one about a probability distribution. Okay, for a probability distribution, all the values must be positive. You can't have a negative, right? So either 0 or positive values, and then in your probability diagram, they should all add to 1. Let's start on the bottom here. These are negative. That's my last one. These are negative. That's no good. There's a negative 0.1. No way. You can't have a negative probability. So we're left with A, B, and C. 0.3 plus 0.2 is 0.5 plus 1 more is 0.6. No, it should add to 1. 0.2 plus 0.6 is 0.8. Plus 0.2 is 1, plus another 0.1 is 1.1. They cannot exceed 1. Okay, and finally up here, there are 10 values, 0.1, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. If I add those up, it adds the 1. A is the correct choice there. Okay, so that other one that we saw in 1 through 20 is kind of worthless. This is a good problem here, though. Guys, we're going so quick. We're almost at 30. We're at 30 already here. Okay. For a given school year, a reporter has been told that the average teacher's salary was $59,500 with a standard deviation of $17,200. The reporter also knows that teachers will be receiving raises of 3.25% for the next school year. What would the reporter write for the new average teacher's salary and standard deviation? Okay, so here's the deal. The salary, all right, everyone added not the same amount. Everyone added 3.25%. So if I was making $100,000, that was twice as much as I got if I was making $50,000. 3.25% of each is a different amount, okay? So that's going to change that for sure. So I'm going to multiply, I'm going to get 3.25% more, everyone will. So I'll multiply that by 59,500, that's my increase, and I'll add that onto that. All right, the tricky part is the standard deviation, okay? All right, if you remember, if I add a constant value, so let's pretend everyone that made this 50, or not everyone, all the teachers, their average was 59,500. If they each got a $1,000 raise, okay, then the lowest teacher would move up 1,000, the highest teacher would move up 1,000, and the spread between them would remain the same. So the standard deviation in that case wouldn't change at all. Okay, but ours, we're multiplying by something them all, and they're all different. So think about our range. If I go from 0 to 50, and I times them all by 2, now it goes from 0 to 200. Do you see how that multiplied? So I need to multiply the standard deviation by that 0.0325 as well as the mean. Okay, so let's have a look at that. Okay, so here we go. All right, in our problem, we start out with that mean and that standard deviation. All salaries raised by 3.25%. So the increase was 3.25% of the salary. If I add that on to that salary, I have a little decimal there, but it's approximately $61,434 as my new mean salary. Okay, and my standard deviation, again, since we're multiplying, it's going to change the measure of spread. So we go ahead and multiply that by the standard deviation as well. That's my increase in standard deviation. So this plus that value equals 17,759. Okay, that's the correct answer, which is the E on your paper. Again, the problem I would most likely expect you to see, okay, if a constant was added to each again, if each person got a $1,000 increase, my mean would be, and I didn't write this in there somewhere, it would be 59,500 plus 1,000, which would make it, what, $60,500. And notice they have units. The mean and the standard deviation always have the same units. Okay? All right? And then my standard deviation, again, the lowest teacher would move up by 1,000, and the highest teacher, whatever they're at, they'd move up by 1,000. The spread of those variables or those salaries has not changed a bit, so the standard deviation would just remain at 17,200, okay? So adding or subtracting a constant value does no change to any measurement of spread, but multiplying does. Okay? 21 through 30. Again, we're doing great except for me talking. Thank you, guys.